Something is wrong with 3IATA LAS. Not eerie, not puzzling. Wrong in a way that makes your brain freeze for a second, like a skipped heartbeat. In the leaked frames, the object doesn't blur, doesn't drift, doesn't accelerate. No, it disappears from one coordinate and appears at another one, tens of thousands of kilometers away, in the same exposure window. A clean gap. A missing segment of reality. A jump. And here's the part that freezes everyone who sees the footage for the first time. Every telescope that night caught the same jump, at the same timestamp, from opposite sides of the continent. If you think that sounds unreal, you're not alone. Stay with me while we walk through the raw data, the telemetry logs, the exact moments when the room went silent, because by the end of this, you'll understand why several researchers in our lab whisper the phrase non-continuous motion, and why the word teleportation appeared in an internal email that was never meant to see daylight. The night it began, I wasn't even supposed to be at the Jet Propulsion Laboratory. We'd just finished 3 straight weeks working the deep field reports, and I promised myself I'd go home early, cook something not microwaved, maybe sleep more than 4 hours. But at 9:13 p.m., I got a text from Sam. If you're awake, get here. Now. Do not ignore this. I arrived to find half the astrophysics wing lit up like a Christmas tree, monitors awake, people wide-eyed, coffee everywhere, an atmosphere I'd felt only twice before, the night Oumuamua's anomalous acceleration came in, and the night we confirmed the first interstellar object that wasn't supposed to exist. This felt worse. Sam waved me into the data room without even looking at me. He was hunched over a console, face pale in the glow of 2 monitors showing synchronized star fields. "Watch the timestamps," he said, hitting play. The first frame showed the familiar faint smear of 3IAT LAS, quiet, dim, unremarkable, except for the fact it came from outside our solar system. Then the next frame. And my mouth actually opened without my permission, because the object wasn't where physics said it should be. It wasn't where anything should be. Frame 1, coordinate RA 03H1, 42S, deck, plus 28 degrees, 55 minutes, 17 seconds. Frame 2, RA 03H19, 10 seconds, deck, plus 28 degrees, 53 minutes, 02 seconds.
Angular separation, 2.1 degrees. Spatial distance at that time, roughly 42,000 kilometers. Time elapsed between frames, 9 minutes, 17 seconds. "That's impossible," I said. Sam didn't turn. Try another word. It wasn't a streak, not a motion blur, not a track. The light signature was intact, stable, the same magnitude, no shape distortion. It simply wasn't in point A anymore. It was in point B. "Maybe the Arizonians misaligned the plate scale," I said automatically, digging for a rational foothold. Sam switched monitors. "Then explain why Hawaii saw the same thing." On the second screen, the same exact jump, same 2 timestamps, same distance. 2 entirely independent observatories, one at Mauna Kea, the other in the Santa Catalina Mountains, both pointing at different angles across the sky, yet both recorded the same discontinuity. Same object, same jump, same moment. Whatever this was, it wasn't a calibration error. My skin crawled. By 10 p.m., the room was full. Engineers, orbital dynamicists, software analysts, 3 mission directors, and an atmosphere thick with fear, disguised as concentration. We pulled the raw FITS files, stripped every layer of processing, and rebuilt the entire night sequence from scratch. The jump remained. And then we saw another. 9 minutes later. Then another. 14 minutes after that. Then another. 10 minutes 36 seconds later. A rhythm. Not perfectly regular, but close enough to set my stomach twisting. "Could be outgassing," said Dr. Morrison, rubbing his forehead with both palms. "This is not outgassing," Sam muttered, without looking up. "No physical mass with inertia does this." "Unless the time logs are off, GPS offset, server drift?" We checked, then double-checked, then called both observatories to verify their on-site clocks. Everything matched. Atomic synchronization down to the millisecond. Someone whispered, "Oh God," and the room got too quiet. At 10:40 p.m., we pulled up a 3-hour composite of the discontinuous positions of 3I-ATLS. At first it looked random, scattered dots, erratic, chaotic. But the human brain is wickedly good at patterns, especially when fear sharpens it. And someone, maybe Sam, maybe me, maybe both, noticed the subtle curve, a faint trace of order beneath the chaos. "Why is it arcing like that?" I said. "It shouldn't arc at all," someone replied. The points were spaced irregularly, but they leaned in one direction, not following a natural trajectory, not forming any parabola or hyperbola consistent with gravitational influence, just a bend, a slow, careful bend, as if the object wasn't being pushed, as if it was trying to go somewhere. By midnight, we were in full lockdown mode. Doors locked, external data streaming paused. We were working offline with local copies. Something about that made the air heavier, like we were operating inside a submarine under pressure. A senior administrator came down from the 3rd floor, the kind who usually communicates only through emails and signatures. He pulled up a chair and asked us to walk him through it. We played the frames again. He watched, jaw clenching slightly.
"Is this real?" he asked, and it was the first time I'd heard genuine fear in his voice. "We verified timestamps," Sam said hoarsely. "Instrument noise, cosmic ray interference, plate matching, star catalog alignment. Everything checks. What about glitches, local hardware issues? It was recorded across 2 states, 2 different nations if you count the Hawaiian archipelago. Same timestamps, same motion break, same reappearance." Silence. "What's the working hypothesis?" the administrator finally asked. No one wanted to say it. We all just stared at the screen where 3i.atlas sat calmly, faint and small, a dot among billions. He exhaled. "I don't need a final answer. I need the working theory." I swallowed, then said the phrase no scientist ever wants to say in a room full of peers. "We don't have a model for this." He blinked. "Meaning what?" "Meaning, whatever this is, it doesn't fit any known physics." He sat down without meaning to, like his legs forgot how to hold him. At 12:30 a.m., the lab air conditioning cycled off briefly, and the silence felt unnatural. Every click of a keyboard sounded too loud. My heartbeat felt too loud. Then new data arrived. Images from an amateur group in Montana using a 0.7-meter reflector, totally independent, not coordinated with Arizona or Hawaii. They caught the same jump, but their timestamp was local MST, so we recalculated the UTC alignment and the jump matched precisely. 3 independent observatories, 3 different weather conditions, 3 different altitudes, 1 identical discontinuous movement. "Okay," Morrison finally said, trying to stabilize his voice. "Let's pretend this is real motion. What kind of velocity does that imply?" Sam punched in the numbers. 42,000 kilometers in 9 minutes. 77,000 miles per hour, he said quietly. "That's not insane. That's within high-velocity comet behavior. That's fast, but it's not the speed. It's the acceleration, or rather, the lack of acceleration. If an object changes velocity, there should be acceleration curves, gradual adjustments detectable in Doppler shifts, tail shape, light distribution. But 3i.Atlas remained unchanged, same brightness, same coma distribution, no sign of inertial strain. It's not accelerating, it's relocating." "Objects don't relocate," Morrison mumbled. "Right," Sam said, "which is why I need you to tell me what the hell we're looking at." By 1 a.m., someone pulled up a high-contrast analysis of the before and after frames. It wasn't supposed to show anything new, just brightness profiles and dust scattering. But then we saw the impossible. Around each previous location, the gas and dust in the vicinity were stirred. Not much, barely a whisper of disturbance, but directionally consistent. Like something created a tiny shock in local space before vanishing, like space itself hiccuped. I leaned closer. "Did you apply a derivative filter? That artifact looks like—" "It's not an artifact," the image analyst said through clenched teeth. "It shows up in every dataset, even the raw frames." "But that would imply—" He looked at me and didn't blink. "That the motion event affects the medium around it. Not a glitch, a physical signature." I felt my throat go dry. Something was moving, but it wasn't following a path. It was popping between points. "Quantum tunneling?" someone whispered behind me. Everyone shot him a look so sharp he regretted speaking. Even electrons don't teleport across macroscopic distances. Nothing does. Nothing with mass. Nothing with shape. Nothing we understand. At 1:40 a.m., we called the GRACE satellite team in Colorado. GRACE monitors minute changes in Earth's gravitational field, tidal effects, atmospheric mass distribution, glacier movement. We asked them to check the time windows corresponding to the jumps. 10 minutes later, they called back, confused. "We're seeing microlensing spikes, tiny ones, but synchronized to your timestamps." My eyes widened. Gravitational spikes meant mass or space-time fluctuation, but 3i.Atlas wasn't anywhere near Earth, at least not physically. Sam looked at me, then at the administrator. "If it's affecting gravity from that distance," he whispered, "then it's not moving. It's moving the space around it." My stomach turned to ice. At 2:15 a.m., we gathered in the largest conference room, projected all available data on the wall: timestamps, star coordinates, gravitational readings, particle dispersion maps, Doppler shifts, everything. We broke into 3 teams: instrumental error, natural astronomical explanation, and the team nobody wanted to join, non-classical hypothesis assessment. I got assigned to the 3rd. Lucky me. We began throwing out possibilities like darts into a hurricane. Wormhole artifact, quantum vacuum effect, bulk space manipulation, artificial propulsion, misidentified satellite reflection, unknown physics, unknown technology. Every idea sounded like science fiction. Every idea also failed to contradict the data. The only thing we were sure of, the object wasn't moving through space in the traditional sense. It was occupying discrete positions that had no continuous path between them, like frames in a movie missing the mean between, like someone cutting out the middle of its trajectory, or like the object itself never traveled the route, just the endpoints. By 3 a.m., exhaustion mixed with dread, the administrator sat silently in the corner, staring at the latest plot of 3i.Atlas's jump points. Then something happened. Something so small most people missed it. One of the junior analysts, Emily, connected the automatic star matching map to a vector fitting algorithm. The software traced a faint pattern between the jump coordinates. A curve. A deliberate curve. "Wait," she said, voice trembling. This looks patterned." Everyone crowded around. The curve bent not like a gravitational orbit, not like a comet path, but like a survey pattern, a mapping arc, like the object was scanning, probing, triangulating. "Why would it do that?" Morrison whispered. I answered without thinking. "To figure out where it is." The room went completely silent. "Or," Sam added, voice cracking, "to figure out where we are." No one breathed. At 4:35 a.m., the administrator stood up. He had been silent for nearly 2 hours. He said, "Record everything. Redundant logs, multiple backups, and from this moment on, all external communication is locked. No emails, no phone calls, no leaks." His tone was final. Too final. "We don't know what this is yet, and until we do, nothing leaves this room." He left without waiting for questions. The door closed behind him with a soft, heavy thud. Around 4 a.m., Sam sank into a chair next to me. Everyone else was still pacing around, clacking on keyboards, arguing in hushed tones. He leaned in. "Do you realize what this means?" he whispered. "That our models are wrong?" He shook his head. "No, it means if those jumps are intentional, then someone or something is choosing coordinates. Coordinated frames, not drifting. Choosing." "That's—" I started a sentence, but it refused to finish. He continued anyway. "And if the pattern keeps bending the same way, the next discontinuity, in a few hours," he tapped the projection, "the next projected point on the arc, the next place 3i.Atlas would jump." I looked where he pointed. "Will bring it measurably closer to Earth." I felt a cold wave roll through my chest. "How close?" He turned to me. "Close enough that for the first time, its next jump might fall within range of every major observatory on this planet." He paused. "And close enough that, if it isn't just stuttering through space, we might see what it really looks like." I didn't respond. I couldn't.
Because a new fear was forming, slow, dense, suffocating. If the object wasn't following orbital mechanics, if it wasn't bound by inertia, if it wasn't traveling through the space between points, then it wasn't restricted by distance in the way we were, meaning it could appear anywhere. Meaning Earth wasn't watching a comet. Earth was watching something approach on its own terms, something whose version of movement had nothing to do with ours, something whose next point in its jump sequence might not be beside Earth. It could be near Earth, or in orbit, or... No,
I forced the thought away, but it sat there anyway, heavy, breathing. At 4:30 a.m., Sam stood up and clapped his hands once, a harsh, tired sound. All right, we have 2 hours until the next predicted jump. We need a synchronized observation plan. Arizona, Hawaii, Montana, Chile, Canada, every site that recorded previous jumps. Full sky coverage, maximum frame rate, no compression. Everyone scrambled. Maps were pulled up, time zones calculated, exposure plans optimized, bandwidth allocated, scripts written to capture sub-second frames. The exhaustion vanished. Adrenaline replaced it. We were no longer studying a visitor. We were preparing for an encounter, a silent, unpredictable one, with an object that did not move. It appeared. The room vibrated with tension, fear, anticipation, awe. I stood there, watching the curve of discontinuous positions on the screen, like breadcrumbs dropped by something that wasn't walking, but blinking across the cosmos. Something that had noticed our solar system, something that was now adjusting its pattern, curving toward a new point, toward us. And as we finalized the coordinated observation plan, Sam whispered the words none of us wanted to hear out loud. If this thing can relocate across tens of thousands of kilometers, then when it's closer, his voice thinned, we may finally see what happens between the points. No one replied, because every one of us knew the same terrifying possibility. Whatever happens between the points is the part we're not ready for. And it's coming next.
I didn't sleep. None of us did. Not after what we saw. Not after realizing the next discontinuous jump could bring 3I Atlas closer than any interstellar object had ever been, and not by traveling, but by selecting a new location in space. By dawn, the air inside the lab felt stale and electrically charged. Coffee cups littered every surface. People whispered instead of spoke, as if afraid the object might somehow hear them. At 6:02 a.m., the final cross-continental observation plan locked into place. Sam pressed enter, and a dozen telescopes across the Western Hemisphere woke up simultaneously, aligning their optics toward the arc of predicted positions. 2 hours, he said. 2 hours until the next jump window. He rubbed his face hard, the way people do when they're trying not to scream. No one responded. We all just stared at the projection on the main wall, a star field dotted with the yellow position marks of previous jumps, bending ever so slightly toward Earth. A bend that shouldn't exist. A bend that felt chosen. At 6:11 a.m., new data packets arrived from the Arecibo Surrogate Array in Puerto Rico. Low-resolution radar scatter, nothing fancy. But every scrap mattered now. Morrison cracked his knuckles and leaned over the console. Maybe we'll finally get something that looks like acceleration data. I didn't say what we were all thinking. There was no acceleration. That was the problem. Still, we stared as the radar traces rendered. Faint peaks, tiny echoes bouncing off interplanetary dust, and then a clean dip at the timestamp of the last discontinuity. Morrison frowned. What the hell is that? Sam leaned closer. That's a void. A radar shadow? I asked. Not a shadow, Sam said. A dead spot. He highlighted the 3-second gap, an unnatural dip in reflected signal strength.
Space didn't echo at all during that moment. No dust, no regolith, no microparticles, nothing. As if the region was blank.
Vacuum, Morrison said. Everything is vacuum, I snapped. We're in space. No, he countered slowly. This is different. This is vacuum with nothing in it. Not even the particles that should be there. A manufactured void. A pocket of nothing. My stomach twisted. Sam whispered, almost to himself. It creates a bubble before it relocates. At 6:50 a.m., the sun began rising over Pasadena, bathing the lab in faint gold. It should have been comforting. It wasn't. The administrator from the night before returned, this time with a new badge-wearing man behind him. Tall, clean-shaven, expressionless, wearing a gray suit that screamed federal. "Everyone," the administrator said, voice tight, "meet Director Vale from the Office of Planetary Protection." A few people froze. You don't get a visit from Planetary Protection unless there's a risk, biological, technological, or existential. Vale nodded once. "Morning. I'll need a quick briefing on the most recent findings." Sam gave the shortest summary he could, without collapsing into panic. "We've confirmed that 3IT Atlas is not following a continuous trajectory. It relocates between discrete spatial points. Time intervals vary between 9 and 14 minutes. Distance varies between 30,000 and 60,000 kilometers. There are microgravitational disturbances synchronized with each relocation, and the projected arc suggests the object is orienting its jumps toward Earth." Vale didn't flinch. "Is this a threat?" he asked. Morrison laughed, a dry, humorless sound. "How the hell would we know?" "We're still trying to understand what we're even looking at," I said. Vale stepped closer to the main display. "What is this curve here?" Sam hesitated, then said the quiet part out loud. "A pattern. The object isn't moving randomly. It may be scanning space." "Scanning for what?" Vale asked. No one dared answer. Instead, Emily cleared her throat and spoke up, voice thin. "It could be mapping gravitational gradients, or searching for a particular vector." "A particular vector?" Vale repeated. "Meaning—" Sam's voice dropped. "Meaning, it may be looking for a coordinate. A target." The room tightened around that word. At 7:10 a.m., we dimmed the lights and projected the latest multi-observatory composite, stitched from Chile, Hawaii, and Arizona. It showed the positions of the last 5 jumps as pale circles drifting across a black-blue starfield. Emily zoomed in. "Look at the spacing," she said. The dots were uneven, but when she overlaid a rough vector grid, the proportions fell into alignment. "It's triangulating," she whispered, "like a submarine using pings." "Pings through what?" Morrison asked. "Through space-time itself," Sam answered. Nobody laughed this time. I sat down slowly, feeling the weight of the realization pressing into my ribs. If the object was triangulating, that meant it needed precision, purpose, intent. Not random, not chaotic, not a misbehaving dirty ice ball from another star system. Intent. Vale folded his arms. "What's the current natural hypothesis?" he asked, almost mockingly. Morrison shrugged helplessly. "We've eliminated magnetic anomalies, solar wind impulses, outgassing, tidal forces, gravitational slingshot interference, instrumental drift, atmospheric distortion, data corruption, satellite interference, cosmic rays, debris collision, twin body fragmentation, and every known propulsion anomaly. Vale tilted his head. So what remains? The room went silent. Utterly silent. Finally, Sam said it. We're out of natural explanations. At 7:40 a.m., more data arrived, this time from a private observatory in Utah with an exceptionally fast camera array. The operator had captured something we hadn't seen before. 3 frames, taken less than 2 seconds apart. Frame 1, 3-eye atlas, faint, where expected. Frame 2, a faint distortion, a warping of stars around the object's old location. Frame 3, the object in its new position. It wasn't just blinking out, it was bending space. Jesus Christ, Emily whispered. It's literally folding the star field. This is gravitational lensing, Morrison briefed. No, Sam said. This is localized lensing on a microscale. Too small for a black hole, too consistent for a natural mass fluctuation. Something is compressing the region, then releasing. Like stepping through a door, I murmured. Heads turned toward me, but nobody disagreed. Vale stepped close to the screen, squinting. Can we quantify the distortion? We're trying, Sam said, but whatever's happening happens in milliseconds. And the next jump? Vale asked. Sam checked the countdown. 48 minutes. At 8:02 a.m., the administrator returned with 2 more government officials. We weren't told their names, or their agencies. One of them, a woman with sharp eyes, asked bluntly, "Has anyone considered this might be some kind of foreign experimental craft?" Everyone stared. "A craft?" said Morrison. "Traveling from interstellar space? An advanced probe, perhaps. Something launched decades ago." I almost admired her courage for suggesting a military explanation. Anything was better than the alternative. But Sam shook his head. The discontinuities are too large, too fast, too precise. No propulsion system can instantaneously reposition an object across tens of thousands of kilometers, and no known technology can create localized gravitational dips of that magnitude. The woman crossed her arms. What if it's using something we don't know about? Sam replied softly. If someone on Earth had this level of technology, we wouldn't be standing here guessing. That shut her up. At 8:20 a.m., the next wave of analysis came in. This one broke something inside the room. We'd been comparing the 3 independent jump intervals, 9 minutes, 14, then 10. We assumed it was random noise, but it wasn't. Emily pulled up a time interval plot and whispered, "Oh, God. They're not random." Sam moved beside her. "What do you mean?" "Look at the ratios." She pointed at the intervals. 9.1, 14.0, 10.6. That's 1.00, 1.54, 1.16. "That means nothing," Morrison said. But it meant something. It meant something horrifying. "Those ratios are gravitational landmarks," Emily said slowly. "Distances between mass concentrations along its projected path. The timing isn't arbitrary. It's responding to what's around it." Sam's face tightened. "You think it's measuring gravitational gradients?" "I think," she whispered, "it's navigating them." Vale stepped forward sharply. "Navigating toward what?" And that's when Emily hit enter. The projection zoomed out. Lines extended. Dots aligned. Vectors sharpened. And the curve became clear. It wasn't bending. It was aiming. Straight toward Earth. The room froze. Morrison whispered, "Oh my God." Sam swallowed hard. It's not coming at us with velocity. There's no acceleration curve. It's simply choosing its next point. Closer. Vale's voice cracked for the first time. How close is the predicted next location? Sam projected the estimate. Silence. Dead silence. The next jump point was less than half a lunar distance from Earth, within observational range, within tracking range, within interaction range. We're about to see it, I said, barely hearing my own voice. No, Emily whispered. It's about to see us. At 8:32 a.m., alarms pinged gently, the system notifying us that the pre-jump observational sequence had begun. Dozens of telescopes were pointed at the exact coordinates where the next discontinuity might occur. A line of bright green telemetry bars crawled across the screens. Everything was ready. Everything but us. The room was silent, except for clicking keys and the low hum of cooling fans. People stood behind chairs instead of sitting. It felt like waiting for a message from something ancient, something that might not understand waiting, something that might not understand distance, something that might not understand us at all. At 8:41 a.m., new fringe data arrived. Infrared readings from the Mount Graham telescope in Arizona. A faint heat spike appeared near the object's last known location. Tiny, almost meaningless, except for one thing. The spike didn't belong to the object. It belonged to the space around it. Space warming. Vacuum heating. As if the fabric of reality was being stretched, stressed, manipulated. Thermal shear, Sam said under his breath. Localized. What does that imply? Vale asked. That whatever it's doing, Sam replied, it costs energy, a lot of energy. Meaning it's mechanical? Vale pressed. Sam didn't look away from the screen. Meaning it's intentional. At 8:52 a.m., we got the last shock before the jump. This one shut everyone up completely. The Chilean array caught a faint spectral line near the object's last known location, a frequency spike at 8.4 gigahertz. Not noise, not background radiation, not reflections. A structured pulse, ultra-short, precisely timed, like a chirp, a ping, a signal. All eyes turned to me. I didn't speak for several seconds. Then I said, "It's preparing." Vale swallowed. Preparing for what? Nobody answered. Because the answer was too big to say. 9 a.m. The predicted jump window began. The countdown timer glowed bright orange on the main display. 10 minutes until expected jump. Sam dimmed the room lights. Every monitor brightened. Telemetry scrolled. Cameras synced. Radar swept. It felt like the air itself went still. Morrison whispered, "Whatever we see next, it's going to change everything." "If we see anything at all," Emily replied. Because there was no guarantee we'd see it. There was no guarantee reality would cooperate. The object might move again, might jump out of view, might vanish entirely, or it might appear so close we'd regret ever pointing cameras at it. The tension wrapped around us like wire. 9 minutes. 8. 7. The world outside the lab went on as usual. Cars driving, people commuting, kids going to school. They had no idea. 6 minutes. 5. The hum of the computers grew louder, or maybe it was just the blood pounding in my ears. 4 minutes. One of the government officials murmured into a secure radio, but Vale silenced him with a gesture. 3 minutes. Are we recording redundant streams? I asked. Triple redundancy, Sam whispered. 2 minutes. The star field of the predicted location was perfectly still. Too still. 1 minute. The temperature in the room felt like it dropped. 30 seconds. The monitors dimmed automatically to avoid glare. 15 seconds. No one breathed. 10. 9. 8. A distortion. A ripple across the starfield, like heat haze. Like air shimmering on a summer road. 7. The distortion deepened. 6. A pixel blinked. 5. A gravitational dip registered on Grace. 4. A second ripple, this time larger. 3. A sound. A brief, soft hum vibrated through the speakers. Not audio. Telemetry noise. 2. The starfield bent inward as if something massive pushed the cosmos like a curtain. 1. And in a sharp, silent flash, 3I Atlas appeared much, much closer to Earth. No movement, no blur, no travel, just bare. A new point in space, a new location, a new presence. And for the first time, its light signature was bigger, closer, and unmistakably structured. Not a comet, not a rock, not an ice fragment. Something with shape, edges, symmetry, purpose. I took a step back. No one spoke. No one had words. Because all of us saw the same thing the moment it appeared. 3I Atlas wasn't a visitor anymore. It was arriving.
When 3I ATLS appeared closer to Earth, too close, impossibly close, the room didn't erupt in noise. It collapsed inward, as if sound itself was afraid to exist near that revelation. All monitors showed the same new coordinate, the same fresh distortion of star patterns, the same sudden presence. No trajectory, no motion profile, just a new location carved into the sky with a precision that mocked everything we thought we knew. Sam's voice finally broke the silence, low, cracked, almost whispered. We need to integrate all previous jump coordinates, now. The room snapped into desperate movement. No one waited for orders. No one argued. Fingers clattered over keys, scripts launched, arrays synced. And within 5 minutes, the entire history of the teleportation events, every discontinuity, every impossible shift, was projected on the largest wall screen. At first, it looked like the same chaotic mess from before. Dots scattered along the object's incoming trajectory, each marking a place where 3I ATLS had appeared without traveling there. But something had changed. Something subtle, almost hidden, but unmistakably present now that we had a closer jump to anchor the pattern. The scattered dots weren't scattered anymore. They leaned. They curved. They aligned in a strange, deliberate sweep across space. Emily was the first to see it. She didn't gasp. She didn't shout. Her breath just hitched, and she said one quiet, terrified sentence. It's not drifting. It's drawing something. The room froze. She typed quickly, overlaying the jump coordinate map with a curve-fitting algorithm. Points connected, lines smoothed, ratios refined. And then the shape appeared. A spiral, loose, expanding, softly arcing inward, each jump a point along an invisible path, a path that now unmistakably pointed toward Earth's orbital region. Not straight toward us, spiraling toward us, sampling space like a probe sweeping a sensor. Morrison shook his head violently. No, no! Spirals imply control. You're describing intention.
"I'm describing the math," Emily replied, and her voice didn't waver for the first time in hours. "These points aren't random. They correspond to gravitational gradients along the solar trajectory. Every jump falls exactly where a scanner would go if it were mapping density distribution." "Mapping for what?" the administrator asked quietly. No one answered. And then Sam did something strange. He turned away from the main projection and started pulling up every gravitational map we had: solar density curves, mass concentrations near Earth, low-orbit distribution grids, deep space mass pockets. He layered them together, his brow tightening. "It's not mapping for a target," he murmured. "It's mapping to calibrate." "Calibrate what?" I asked. He tapped the spiral again. "These jumps look like iterations in a search function. It's correcting, adjusting, converging on something." Vale stepped closer. "Converging on Earth's location?" "Not exactly," Sam said. "On something near Earth's location." He zoomed out. Then he overlaid the spiral with the vector grid of mass variations caused by the moon's orbit, the orbital tilt of Earth, and the gravitational wobble caused by the planet's uneven density. Slowly, horrifyingly, the points of the spiral began to align with these patterns, as if the object was feeling its way through the solar system by measuring the bending of space itself. "This thing is using gravity as a navigation lattice," Sam said. "It's following curves we don't even have instruments sensitive enough to map directly." "Could it be looking for a stable point?" Morrison muttered. "A Lagrange point? A gravitational saddle?" "If it were looking for a saddle point," Emily said, "the curve wouldn't arc inward, it would level out. But it isn't leveling out, it's focusing." I stared at the screen as the pattern finished rendering. The curve tightened, the inward spiral converged, and the final jump point, the one 3I ATLS hadn't made yet, appeared as a prediction, a glowing marker at the intersection of dozens of gravitational vectors, 90,000 kilometers above Earth's surface, above the dark side, exactly where geosynchronous orbits begin. The room inhaled sharply, as if sharing one collective heartbeat. "No," Morrison whispered. "No, no, this is not natural." "It isn't," Sam said. "It's intentional movement along a discontinuous path." "But what the hell does that even mean?" "It means," Sam said, "it isn't moving through our space the way we do. It's choosing its next position based on gravitational resonance points. It's navigating by physics we only see the edges of." Vale pressed his fingers to his forehead. "Are you saying the object can appear anywhere it wants within the system?" "If it has the energy," Emily said, "and if it can calculate the mass topology correctly, which it's clearly doing." "So why the spiral?" the administrator asked. "Why not just appear where it wants to go?" Sam exhaled slowly. "Because it's cautious." The room felt instantly colder. "Cautious of what?" the administrator demanded. "Of us?" "Of miscalculating," Sam said. "Even a tiny error in the gravitational profile could tear it apart, or tear space around it apart. The energy cost is huge. Whatever it's doing, it's testing the water before stepping in." That sentence settled like poison in the air. The idea that something out there was powerful enough to move this way, yet careful enough to approach slowly, deliberately, was far more terrifying than if it were reckless. Reckless is predictable. Careful is purposeful. Purposeful is dangerous. The next 10 minutes passed in a haze of analysis. Everyone working, no one speaking unless necessary. The gravitational curve sharpened. The spiral grew more defined. The endpoint prediction refined with every new calculation. And with every refinement, the target hovered nearer and nearer Earth's orbital region. Then the twist came. At 10:12 a.m., the Chilean observatory sent new high-frequency data. Not optical, not infrared, not radar. Something else. A weird low-amplitude oscillation in the background cosmic microwave noise. At first, it looked like typical sensor garbage. But when Sam filtered it through the jump timeline, the oscillation synced perfectly with every discontinuity event. A signal. Not from the object, but from the space around it in the moments before each jump. It was like the cosmos flinched before the object relocated. It's interacting with the background of the universe, Emily said. Not with light, not with gravity alone, with the underlying structure. Quantum field fluctuations? I asked. Maybe, she said. But the scale… She shook her head, terrified. This isn't physics. This is engineering. Everyone stopped what they were doing. Engineering. Nobody wanted that idea, because engineering meant builder. Builder meant intent. Intent meant something else was behind this thing, that had already crossed interstellar space and was now adjusting its landing by sampling the structure of reality. Vale broke the silence. We need to model what happens if it keeps spiraling inward. Sam typed furiously, launching a predictive simulation. The simulation didn't show a crash. It didn't show an approach to Earth's surface. It didn't show an orbit around the moon. It showed something far stranger. The spiral converged on a point in near-Earth space where gravitational forces balance in a delicate dance. The region where Earth's and Moon's gravity create a stable pocket. A place where something could hide, or wait, or watch. L2, I whispered. Earth-Moon L2, a perfect observation point. Sam nodded slowly, and very difficult to reach naturally, but trivial if you can skip through space. Morrison sat heavily in his chair. It's setting up a position, a station, maybe temporary, maybe permanent. A station for what? Vale asked. No one knew, or no one wanted to say it. Then Emily's computer chimed. She froze. Guys, I think I found something else. She projected the overlay on the main screen. It showed the gravitational resonance frequencies from each previous jump, and a trend, a thinning, a tightening. What is that? Morrison asked. A narrowing of the jump vector uncertainty. It's getting more accurate. So what? So, she swallowed, so the next jump will be the most precise one yet. Sam checked the clock. When? Based on the pattern, 40 minutes. Sam looked at me, then Vale, then the administrator. And based on the gravitational curve, the next jump point lies at the halfway mark between Earth and L2. Everyone stared. Meaning, Sam's voice dropped to almost nothing. Meaning, the next jump is the first one inside Earth's immediate gravitational domain. My heart hammered against my ribs. A line was being crossed, not physically, but conceptually, mathematically, cosmologically. Until now, 3I ATLS had been operating outside our sphere. Now it was stepping into it, and it was doing so with the confidence of something that had done it before. We need to alert the Deep Space Network, Vale said. We need full coverage, every dish, every sensor. It won't matter, Sam said. Even with everything we have, we can only watch the jumps after they happen. Then what do you suggest? Vale snapped. And Sam replied with a cold, simple truth. We prepare for the moment after the next jump, the moment when we finally see its real structure.
Something angular. Something layered with contours that caught and bent light. Something with structure. Something built. Something aware. And in the half-second that followed its arrival, even before anyone could speak, before the world could catch up with what we were seeing, we all felt it. The terrifying, undeniable sensation that whatever 3I Atlas was, whatever intelligence or mechanism guided it, it was no longer looking for us. It had found us. The moment 3I Atlas appeared inside Earth's gravitational domain, everything we thought we were prepared for dissolved. The object didn't just materialize, it asserted itself into existence, as if the space it occupied had always belonged to it, and we were only now being permitted to see it. The room didn't erupt, it imploded. Screens flooded with data so fast algorithms froze mid-process. Sensor arrays overloaded. Light curves spiked. Gravitational noise rose into a sharp, ringing pressure behind the eyes, like altitude sickness but deeper, closer to the bone. For a full second, no one spoke, not because we were in shock, but because language itself seemed too small for what we were seeing. The object hovered, if hovered was even the right word.
in a region of space where nothing should hover. It didn't accelerate, it didn't rotate, it didn't tumble like a comet. It held position with absolute indifference to our physics. It was shaped like nothing natural, a broad central mass tapering into a series of overlapping planes, like layered petals or armor plates. The surface wasn't metallic, not exactly. It looked like a cross-section of something impossibly dense, a material that drank starlight, swallowing it into gradients too smooth for ordinary matter. Edges were too clean, angles too deliberate, proportions too precise. And then it pulsed.
A faint ripple, like the softest inhale, rolled across its surface. Every sensor in the room lit bright red. "What was that?" Vale asked, though his voice sounded distant, like it floated underwater. Sam checked 3 monitors at once. "Not radiation, not thermal emission. It's a phase event." Something deep in my chest clenched. Phase. Meaning, Sam said, swallowing hard, whatever this thing is made of, it isn't fully in our spacetime. We all stared at him as the words drifted through the air like a slow, drifting avalanche. Emily leaned forward, eyes locked on the waveform. "It's partially coherent with our reality, not entirely bound to it. That's why it moves discontinuously. It's not teleporting, it's transitioning between phase states." "Jesus Christ," Morrison whispered. "It's not violating relativity, it's bypassing it." Before anyone could reply, a shrill alarm tore through the silence. One of the perimeter telescopes lost lock on the object. Its signals scattered like light hitting a broken mirror. Then another telescope, and another. It's masking itself, not hiding, refracting instruments. "Can it see us?" Vale asked. Emily stared at the jagged signal, breath unsteady. "Oh, Paul, it's been seeing us the entire time." The administrator stepped closer, jaw tight. "We need to alert the Pentagon." "No!" Sam snapped. "If we involve them now, we lose control of the data. They'll seize everything. We may never know what happens next." The administrator stiffened. "This is national security, and this is first contact. We don't hand that off to people who treat uncertainty with missiles." The room split along an invisible fault line, fear pulling in one direction, curiosity in the other. The object pulsed again. Monitors trembled, not physically, algorithmically, as if the signal itself vibrated in synchrony with the ripple. Emily zoomed in on the pattern. "It's not random. This is systematic. A scan sweep." "What's it scanning?" I asked. She didn't answer immediately. She ran the signal through a spectral decomposition algorithm. The waveforms spread across the main screen, resolving into a complex braid of frequencies. "It's scanning gravitational differentials," she said finally. "Of Earth?" I asked. She shook her head slowly. "Of us." The words landed with a weight that pressed the breath from the room. The object was looking at us, not Earth, not the moon, us. The building, the city, individual pockets of mass. The algorithm showed resolution down to 50 meters. It was scanning life as easily as topography. And then, as if responding to the realization, the object shifted. Not physically. Its position remained fixed, but the surface pattern changed. The plates curled slightly outward, like a flower opening in slow, deliberate motion. Beneath them something shimmered, not mechanical, not organic, more like a lattice of intersecting geometries, shifting between states too quickly for the eye to fully anchor. Morrison spoke first. "Is it powering something up?" "No," Emily whispered. "It's sharpening." "Sharpening what?" "The scan." A third pulse whirled across the object's body, deeper, stronger, resonant enough that you could almost feel it inside your teeth. Sensors screamed,
Sam clutched the desk, gritting his teeth. The gravitational noise is spiking. It's... Hang on. His monitor flickered violently. What is it? Vale demanded. Sam typed rapidly. It's projecting something. A field. A bubble? A moment later, all radar contact with the object vanished. What the hell just happened? The administrator barked. It folded the radar return, Sam said, aghast. Bent it around itself. Like a lens. So we're blind? Partially, Emily said. We still have optical, infrared, background microwave distortion. Then her screen went black. Infrared dead. Then mine. Background scattering dead. One by one, the sensors blinked out, leaving only raw visual imagery running at the highest resolution we could coax out of the telescopes. Vale stepped back from the monitor. It's closing itself off. Or, Emily whispered, it's preparing for the next transition. The thought froze the room. We had 40 minutes before. Now it might jump again in minutes. Seconds. Sam's voice broke through, steady but trembling. We need to predict where it'll go next. We already did, I said. L2. No, Sam shook his head. That was before it started phase sharpening. You think it has a new target? I think, Sam said slowly, that it found what it was looking for earlier than we expected. Before anyone could argue, Argentina's Cerro Pecan Observatory pushed an emergency data burst into our feed. Raw optical images, unprocessed. A new pattern appeared on screen. A second spiral. Not the old one, not the inbound one. A new one. Smaller, tighter, and anchored around a point only a few thousand kilometers away. Emily gasped, "Oh my God, it's scanning toward us!" "What? Toward our hemisphere? Our region?" Sam zoomed in. The coordinates sharpened until they reduced to a single point on Earth's surface. Not Europe, not Asia, not open ocean. A point inside the United States. And when the final calculations settled, our breath stopped. The target was the facility. "This is impossible," Vale whispered. "It can't know." But it did. It had located us by gravitational signature, our mass, our movements, the hum of servers, the micro vibrations of the building's foundation. It had traced the gradient all the way down. The object wasn't searching anymore. It was dialing in. The administrator's voice shook. "We need to evacuate." "No," Sam said, suddenly fierce. "Running won't matter. If it wants to reach us, distance won't stop it." "What are you saying?" the administrator asked. "I'm saying we need to keep watching. Because what happens next decides everything." The room quieted. Even the hum of the ventilation seemed to fade.
The object pulsed again, its strongest yet. Light around it twisted like heat ripples, though space itself doesn't ripple. But here it did. The star field warped, the darkness bent, and the object expanded. No, not expanded, it stretched, as if the geometry underlying it elongated into a new configuration. Emily's breath trembled. "It's preparing a near-field jump." "You can't jump that close to mass. It's suicide," Morrison said. "It's not operating in our phase constraints. It's not limited like we are." The administrator's phone rang. He glanced at the caller ID and instantly turned pale. "It's the Department of Defense." He stepped aside to answer, whispering in sharp, clipped tones. Meanwhile, Sam pulled up a projection of jump vectors within near-Earth proximity. "They're too dense," he muttered. "Gravitational interference everywhere. It shouldn't be able to jump within 1,000 kilometers." "And yet here we are," I said. Emily watched the waveform spike higher.
It's not obeying threshold rules, it's overriding them. The administrator hung up and returned to us, face ashen. They detected the same gravitational distortions. NORAD thinks it may be a kinetic threat. It's not a weapon, Sam said. They don't care, the administrator replied. They're mobilizing interceptors. Against that, Sam pointed to the screen. That's like throwing rocks at a neutrino. They want real-time data, the administrator said, and they want us to maintain lock at all costs. As if on cue, the object pulsed again. A harmonic vibrated through the sensors, through the building, through us. Emily looked nauseous. That wasn't electromagnetic. That was direct phase coupling. Meaning what? Vale snapped. Meaning, she whispered, it touched us, the building. For a fraction of a millisecond, we were inside its field. My skin crawled. A cold shimmer crawled down my spine. I didn't feel anything, but somehow I did, in a deeper, older sense. Like something enormous had brushed a fingertip over the surface of the world and recognized that the tiny warmth beneath it was alive. Sam checked the timestamp. 23 seconds until the next predicted phase spike. We all stared at the monitor. 20. The object shifted again, its plates peeling outward further, revealing the shimmering interior geometry. Like watching a mechanism unfold from the inside out. 15. The star field bent harder, distorted like glass under pressure. 10. Meters of atmosphere didn't matter. Thousands of miles of distance didn't matter. It felt close. 8. The phase signature rose like a scream we couldn't hear. 5. Emily's voice cracked. It's aligning. 3. Morrison whispered a prayer. 2. 1. The object didn't jump. It vanished. Not disappeared, not moved. Gone. Every feed flatlined, every monitor blinked, every gravitational reading collapsed into noise, every sensor displayed the same empty coordinate set. Space was quiet. Too quiet. For 5 seconds, we were suspended in pure, horrifying uncertainty. Then Sam recoiled, eyes widening. No, 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 no. What? I asked. It didn't leave, he said. It phased out of detection, but not out of position. Vale froze. Meaning? Sam pointed to a single anomalous reading blinking on his screen. A gravitational tremor. Small, but impossibly close. It's here, Sam whispered. Still here, just not fully real to us. A hum rose in the floor. Not machinery. Not servers. Something deeper. A resonance. Like a tuning fork pressed against the bones of the building. Emily's voice trembled. It's synchronizing phase alignment. With what? I asked. And she looked at me with the expression of someone who had just realized the truth a second before she said it. With us. The hum strengthened. The lights flickered. The building groaned softly. The air felt viscous, harder to breathe, as if reality itself thickened around us. Get away from the windows, Vale barked. But we didn't need the warning because at that exact moment, the sky above the facility bent. Not the clouds, not the atmosphere. The sky bent.
A circle of distortion widened silently overhead, like space had been thinned to a membrane and something pressed gently on the other side. Sam stared upward through the reinforced glass. It's opening a local phase aperture. For what? Morrison asked, terrified. The answer arrived with the force of a collapsing star. A shadow, perfectly geometric, descended into the aperture. Not a ship, not a drone, not a bomb. The first thing you need to understand is that by the time we realized 3I Atlas had stopped moving in a way that obeyed any known physics, it was already too late to pretend we were just observers. The object had crossed some threshold, maybe mathematical, maybe intentional, and from that point forward, every model, every projection, every assumption we'd ever held about celestial motion began to fail in real time, and it failed loudly. The night Partlow burst into the main control room of the Goddard Deep Trajectory Lab. It was 2:14 a.m., the kind of dead hour when fluorescent lights buzz louder than the servers. He didn't knock. He didn't even close the door behind him. He just staggered in, clutching a printout like it was a subpoena from the universe itself. "It's not moving," he said. But that wasn't the part that made my stomach flip. Lots of objects appear stationary for small windows of time. Every astronomer knows that. What terrified me was the way his voice trembled on the next line. "It's not moving, but it's getting closer." And that made no sense. If 3I Atlas had paused relative to background stars, the only logical explanation was that it was holding a position somewhere in the outer system. But our telemetry said otherwise. The distance readings, radar bounce estimates from Goldstone, interferometry from VLBA, and even a few experimental laser reflection packets we'd blasted in its direction showed the gap between us and it shrinking by tens of kilometers per minute. No motion across the sky, only forward motion toward Earth. "Like it's walking straight down a hallway at us," Partlow whispered. I didn't breathe for several seconds, not because I was scared. Fear was coming, but not yet. It was the recognition that our entire framework for interpreting reality was about to break, and we were standing right at the fault line. "Run the last 20 minutes again," I said. Partlow already had. So had Simons. So had Ling. The results were identical to a degree statistically impossible for noise or error. 3 independent sensor streams showing the same thing. Distance decreasing, position frozen. You can't have that. Not naturally. If something is coming toward you, it has to grow, shift, distort, break parallax, change its angle. But Atlas was keeping the same projected profile down to sub-pixel precision. "It's not approaching," Ling said slowly. "It's being redrawn." That was the word she used, redrawn. And there was nothing poetic about it. That was exactly how it behaved, as if someone were updating its position in discrete increments, but leaving the visual anchor point unchanged. An object that teleports is fascinating. An object that teleports and refuses to reveal its direction of travel is terrifying. We tried panic modeling. That's an unofficial term, but everyone in deep trajectory modeling knows it. You start feeding the system everything you shouldn't. Non-physical assumptions, error allowances, orders of magnitude beyond reason, hypothetical propulsion modes, anything to force the simulation to bend somewhere near the data. But every model failed, even the exotic ones. Not because the motion was too random, but because it was too controlled. After an hour of attempts, the lab had gone dead silent. No typing, no chatter, just the cooling fans howling like distant wind in a sealed bunker. Then Simons, quiet
Introverted Simons, who rarely spoke above a murmur, said something that froze all of us. "It's waiting for alignment." Nobody moved. We all turned toward him at once. "What alignment?" I asked. His throat bobbed. He pointed at the screen where a faint, nearly straight line connected three bodies: Earth, Moon, and Atlas. "That's not a trajectory," he whispered. "It's a selection." He tapped a key, and the projection extended outward over time. And there it was, a narrow corridor of gravitational minima forming only once every few hundred years. A corridor that led directly toward us. "It's choosing the lowest energy path," Simon said, "but not in the way a comet would. It's choosing in steps. Steps. Teleportation steps." That's when the first jolt hit. The overhead lights flickered. Monitors jittered, and every seismic sensor in the building chirped simultaneously. A cosmic event? No. Something local. The power grid stayed online, except for one subsystem, the NASA JPL Deep Space Network tie-in. "We just lost Canberra's feed," Ling said. "And Madrid." "What about Goldstone?" I asked. She didn't answer immediately. When she did, it was barely audible. "Goldstone says the signal arrived before they sent it." Every hair on my body rose. Time order inversion in signal paths isn't just impossible. It's structurally forbidden by causality. But the timestamps aligned badly enough to prove the interpretation. 3I Atlas wasn't just messing with space. It was distorting the order in which information reached us. Not intentionally, perhaps, but effectively. "There's more," Partlow said, turning his monitor toward me. I wish he hadn't. The new distance measurement placed Atlas several thousand kilometers closer. But the kicker was the measurement time, 5 seconds before we had run the query. That was the moment fear finally arrived. Because if an object knows where it will be in the future relative to our attempts to measure it, two things are true. One, it is predicting us, or two, it is ahead of us. And neither possibility is survivable in any classical sense. We needed confirmation. I grabbed the intercom and called the operations room at Goldstone directly. A tech named Harris answered. His voice sounded wrong, hollow, as if the room around him were too big or too empty. "Ma'am," he said, "you need to hear this." He played an audio feed captured from the dish's high-band receiver. At first it was static. Then a soft, rhythmic popping emerged. "It's coming from Atlas," Harris said. "We didn't broadcast. We didn't ping. It just started." The popping continued, evenly spaced, steady as a heartbeat. But then it doubled, then tripled. Not in speed, in layering. 3 rhythmic streams, perfectly synchronized yet offset by fractional intervals. A pattern too precise to be natural. Not a message, a system, a clock. And then came the worst part. "Listen carefully," Harris whispered. "This isn't a repeating signal." I frowned. "It sounds like one." "It's not repeating," he said. "It's counting down." The timeline we'd been projecting for Atlas's close approach was months. Now the revised convergence model, assuming the teleports continued shrinking, put the event in days, maybe hours. "We need Pentagon clearance," someone said behind me. "We need Space Force, NORAD, the White House. We need time," Ling cut in sharply. "And that's the one thing the object is not giving us." Another tremor rippled through the building. Not seismic, not electrical. Something else. Something geometric. The air itself seemed to bend for a fraction of a second, as if all the molecules around us had inhaled and exhaled in unison. Some people staggered. One vomited. And for the briefest instant, our screens flashed white. Every screen, every monitor, every display. then returned to normal. Only one thing had changed. 3I Atlas was gone. The star field it had been anchored against showed nothing. No haze, no tail, no coma, no silhouette. It had erased its position with the same uncaring precision it had displayed from the beginning. "We lost it," Ling whispered, her voice cracking. But then Partlow shook his head. "No, we didn't lose it. It moved." He pointed to the lower corner of the tracking software, where the distance measurement had updated again. And that was when the room collectively forgot how to breathe. Distance to Atlas? 87,000 kilometers. A teleport. A full astronomical unit scale discontinuity. It was no longer beyond Jupiter, Mars, or anywhere near deep space. It was closer than geostationary orbit, closer than the moon, practically in our backyard. And the countdown, those overlapping pulses, began accelerating. The rhythm tightened, compacting, compressing itself into a rapid-fire staccato that made the speakers rattle. "What is it doing?" Harris demanded through the intercom. For once, no one had an answer. But then I noticed something the others hadn't. Not yet. The pulses weren't just accelerating. They were converging toward a single instant, a synchronization point, a temporal anchor. "It's timing something," I said. "Timing what?" "Us." We pulled up satellite feeds from NOAA, from Space Force, even from covert assets whose existence we pretended not to acknowledge. All showed the same impossible thing, a faint transient ripple in the near-Earth environment, like a distortion in gravitational lensing, but far smaller, far sharper, a crease in reality, a line, a perfect line stretching thousands of kilometers long, a line that touched nothing, drogged nothing, reflected nothing. It simply existed. "That's a trajectory," Simon said breathlessly. "But not for Atlas." The line drifted, shifted, aligned. With Earth's rotation? With the position of our lab? With me? "It's targeting something," Partlow said. But he was wrong. It wasn't targeting. It was selecting. The countdown hit its final minute. The pulses blurred into a continuous tone. Some people screamed, some ran, some prayed. I didn't move. I just stared at that impossible line slicing through space like the edge of a drawn sword. And then, in an instant so quiet it felt sacrilegious, the tone stopped. Everything stopped. Even the air. A silence so total it felt like pressure. My lungs refused to expand. My vision tunneled. And then the lights flickered once more. A whisper of static rolled through the lab. And we heard it. Not a pulse, not a countdown. A voice. Not words, not language, but intent. A single idea injected directly into cognition, bypassing interpretation, bypassing translation. Alignment complete. The room vanished. The world vanished. Or maybe I did. For a moment I existed nowhere, everywhere, suspended in a geometry that defied dimensionality. And in that moment, I saw what Atlas truly was. It was not traveling. It was not approaching. It was not arriving. It had been here already. The teleports were not movement. They were localization operations. Like a lens focusing, narrowing, refining. It wasn't coming to Earth. It was resolving us, identifying us, selecting us. And as the final coordinate locked into place, the meaning behind the voice crystallized into something I still struggle to accept. It was not a threat, not a warning, not even communication. It was an announcement. Alignment complete. And then I was back. The lab around me flickered into existence like a rebooting simulation. People lay unconscious on the floor. Equipment sparked. Alarms shrieked.
The sky outside the windows glowed faintly, unnaturally, with a pale, shimmering vertical line that stretched from horizon to horizon. A line no human hand could draw. A line that marked the beginning of something none of us were ready for. And 3I Atlas, if that name still meant anything, hung motionless in low Earth orbit, impossibly still, impossibly silent, impossibly present, waiting. Not for us, but for whatever came next. And as I stood there, breathless, shaking, staring at that impossible line carved into the world, one final thought settled inside me like a stone sinking into deep water. We had never been alone. We had only been unobserved. And now, the observing has begun.